reference types store the memory addresses of the objects. So these types enable efficient programming, and many elegant design patterns feature them. So in this lecture, I will discuss the two kinds of reference types, the pointers and the references. I will also discuss this keyword, const keyword here, and auto keyword along the way. So let's get started by the pointers. So pointers are the fundamental mechanism used to refer to memory addresses. So pointers encode both pieces of information required to interact with another object. So that is the object address and the object type. So you can declare a pointers by type by appending an asterisk to the pointer to types. Here, for example, my ptr. So the format specifier for the pointer is this p here. So for example, to print a value in my ptr, you could use this kind of code here. So the value of my ptr, is p. This is a format specifier for pointer here, and my ptr here. And let's run this here, and as you can see here, the value of my ptr is zeros here. So the pointers are very low-level objects, although they play a central role in most C programs. So C++ offers high-level, sometimes more efficient constructs that obviate the need to deal with the memory addresses directly. So nonetheless, pointers are foundational concept that you will no doubt come across in your system programming travels. So in this section of our auxiliary course, you will learn how to find the address of an object and how to assign the result to a pointer variable. So you will also learn how to perform the opposite operation, which is called the referencing. So the referencing means given a pointer, you can obtain the object residing at the corresponding address. So you will learn more about arrays, so the simplest construct for managing an object collection, as well as how arrays relate to pointers. So as low-level constructs, arrays and pointers are relatively dangerous. So you will learn about what can go wrong when pointer and arrays-based programs go angry. So this lecture introduced two special kinds of pointers. The first is void pointers and std byte pointers. So these are very useful types. They have some special behaviors that you will need to keep in mind. Additionally, you will learn how to encode empty pointers with null ptr and how to use in Boolean expressions to determine whether they are empty or not. So let's get started by the addressing variables in C++ pointers. So you can obtain the address of variables by prepending the address of operator. Actually, I want to note that, so you will keep in mind that operator and operand names in these programming languages. So this is the address of operator. So you might want to use this operator to initialize a pointer so it points to the corresponding variable. Such programming requirements arise very often in operating system programming. So for example, major operating systems such as Windows, Linux, and FreeBSD have interfaces that use pointers here heavily. So now let's get to the practical programming in our course. So integer my pointer here, I will, or just for example my variable. here my variable. So here we will create my variable with this, which I will explain our codes later, as I do always. So my variable here, my variable, and integer my variable address, my variable here, and then printf here, new line, my variable address here. So now I will tell you what these codes are. So you declare the integer my variable and print its value. So then you declare a pointer called my variable address to that integer's address. As you can see here, we use the address of operator. So notice that the asterisk here prepends the pointer and ampersand pretends the my variable here. So finally you point to the pointer to the screen here to reveal the my variable's address. Let's print this out, and as you can see here, we got the my variable equals to 0 and my variable address is this here. This is the this is where my variable resides and lives in our memory, random access memory. So your output should have an identical value, as you can see here, but my variable address should be different each time, as you can see here. So this variation is due to the address space layout randomization, which is a security feature that scrambles the base address of important memory regions to hamper exploitation.